Welcome to the Global AI Tour. And today we're going to talk about machine learning. So basically, what we're going to see today is, we're going to see what is ML and why are we using ML. What is the importance of ML and some of the techniques used in ML. So that is what basically, we're going to see today. And myself, I'm Harikrishnan. So I'm basically into software industry for about 6+ years now. I'm into mobile development and recently into machine learning. And today I'm going to share my experiences and thoughts about machine learning. So the agenda for the day is going to be what is machine learning. So and the various and vendors available in machine learning, and we're going to see some of the key concepts of machine learning and the various terms used in machine learning, and we're gonna see the types of algorithms and specifically about the linear regressions. So that's how the day is all gonna be. So this session is mainly for absolute beginners who want to become an ML expert. So looking so ML is basically looking for patterns and in data and recognize those patterns in the new data. So why are we going to use ML? ML is a key thing that everybody wants to get involved. So even if you look at the trends in technologies, I think ML is the direction to go. So I remember Google CEO says that AI is going to be more important to humanity than fire and electricity. That is the case, ML obviously becomes more important. And we have now self-driving cars, drones, automatic language detections, and fraud detections, robotics, and many more things inside the ML. And what are the techniques used in ML? We'll see some of them and more details in the upcoming slides. So, and before we step in, to start with ML, so some of the applications you need, there are lots of apps and ways for it. You can use Pythons and Jupyter notebooks, and you could download Anaconda and use it. RStudio is free; it's a free version. ML.NET for .NET programmers. If you are a .NET programmer and already using Microsoft products like Visual Studio, C Sharp, then you can use ML.NET to do things in Visual Studio. And I hope you have seen the ML Studio in Satish session in the morning. And fine, so let's jump in. So before we start, it's very important to understand what is artificial intelligence and machine learning and deep learning. So artificial intelligence, so this is a simple Venn diagram. So AI is the broadcast term, and it refers to basically teaching a computer to do something that you would think a human, only human could do. So there are a lot of definitions of AI available in internet, and basically, what we expect is what we understand in simple terms is AI refers to the simulation of human intelligence and in machines that are programmed to think like humans and mimic their actions. So building a smart machine capable of performing tasks that typically require human intelligence. So that's what basically what is AI is all about. A simple example would be, a computer playing a chess, like by calculated trees of moves, pruning the trees, depth searches to choose what is the next move. So to talk about AI, AI will never be AI. And coming to machine learning, so it is basically a subset of AI. And one thing that we all must know is that the traditional programming like C++, Python are gradually fading their way, and we're coming into intelligence programming. So it is not possible to just sit and watch these videos and become an ML expert. To be honest, and what it needs to do is to take away the glimpses from this session and explore more further on what is ML and its importance and techniques. To be honest, and if you put the right effort, you could definitely end up being an ML expert. So, and to give more details, ML involves n number of things. So we have mathematics, we have probability, decision theory, and programming, information theory, and calculus, and so a whole lot of things that's involved in ML. So to state it, in a simple norms, it is basically, ML looks for patterns in data. It generates code based on it, and it recognizes those patterns in the new data. So coming to deep learning, deep learning is something which functions like a human brain. It learns on its job. So something like a small baby. So if we train a baby, what is a dog and how it looks like. Say we list out all the properties of a dog, like it has 4 legs, it will walk like this, it will run like this, it will have ears like this, and so on. And then we show a cat to the baby and ask what it is. So deep learning is something which reads the characteristics of the dog and to match or compare the details and properties what we had trained it, and asks us like, this is something which looks like similar to a dog. Is it a dog? Uh, rather than taking a decision that it is a dog. So now the machine learns on its job. So it is so if you go ahead and further train that it is a cat, now then on showing any cat with any color, the next time the machine predicts that it is a cat. So that is what machine learning, deep learning is all about. And I'm not going to talk much about it. And as we have a session coming up handled by Karthikeyan, who will be talking a lot more deeper on it. And some of the examples of AI would be robots, robotic process automation, and detection and predictions. And we have image recognition, voice to text conversions, and predictions for machine learning. And as I said, we have driverless cars, drones, language detections, and metadata for photo and deep learning. So in this slides, all the sessions, we'll be looking at the machine learning detail. So, so what is machine learning? So, machine learning basically, it finds patterns in large volumes of data and uses those patterns to perform predictive analysis. So, machine learning model falls in two broad categories. So, supervised and unsupervised. In supervised, the model is trained with a large volume of data, and algorithms are then used to predict an outcome from the future inputs. So that is supervised learning is all about. And in unsupervised learning, the computer is not trained really, but it is presented with a set of data and challenged to find relationships between the data. So that's what unsupervised learning is more going to be. So how ML works actually. So as I said, ML is a subset of AI. It is just one facet of to the overall AI. So when you take the traditional programming, so you input a data and the program to the computer, what comes out is the output. Whereas when it comes to machine learning, so you tell the computer what the data is and what the output is based on the historical data, and what comes out is the program or the ML model with which the computer is going to predict on the future input. So there are some of the various vendors available for machine learning. So Microsoft is a famous vendor. You can use Azure machine learning. So Sati should have explained about the ML Studio in the morning sessions, which is cool. And there's some other vendors as well. So apart from Microsoft, Amazon machine learning is there, and Google prediction API is there, and MATLAB is something which supports traditional non-cloud-based ML modeling. And next is the analytics. There are four types of analytics basically. This descriptive analytics is something, what happened. It tells you what has happened. And diagnostic analytics is something which tells you why or how did it happen. And predictive analysis is something which tells you what will happen. So that this is basically on the software engineer's plate, so that's why it is highlighted. So this is more of a role of what a software engineer could do. He could predict what will happen in the future. And prescriptive analysis is something, how we can make it happen in the future. So that's prescriptive analysis. And whatever we talk about AI, ML, and deep learning, everything just revolves around the data. You be a data analyst, a data scientist, or an MI expert, or AL expert, AI expert, or a data scientist, or a cloud architect, whoever it is. Whatever you do, everything just revolves around the data. And there are some of the key concepts that you need to understand if you want to become an ML expert. So I've listed few key concepts over here. So we'll see one by one, so that we could have a better understanding on it. So data explorations. So it is a process of gathering information about a large and often unstructured data in order to find characteristics for focused analysis. So that's what data exploration is all about. And data mining refers to the automated data exploration. And descriptive analytics, I would say, it is a process of analyzing a data set in order to summarize what has happened. So the vast majority of business analytics, such as sales reports, web metrics, and social network analysis, are all descriptive. So predictive analysis, so it is a process of building models from historical or current data in order to forecast the future outcomes. So as I said, no, there are supervised and unsupervised learning under this. Supervised algorithms are trained with labeled data. In other words, data comprised of examples of answers wanted. For instance, um, let's say a model that identifies fraudulent credit card used to be trained from a data set with some labeled data points of known fraudulence and valid charges. So most machine learning is supervised nowadays, and unsupervised learning is it is used on data with no labels, and the goal is to find relationship within the data and learn on the job. For instance, you want to find groupings of customer demographics with similar buying habits. So, and next and last is the training and evaluation. So basically, a model. This is a model training and evaluation. So a machine learning model is an abstraction of question you're trying to answer or the outcome you want to predict. So models are trained and evaluated from the existing data. So training data, So when you train a model from data, you use a known data set and make adjustments to the model based on the data characteristics to get most accurate answer. So in say in Azure machine learning, a model is built from algorithm model that processes training data and functional modules, such as scoring module. So in supervised learning, if you are training a fraud detection model, you use a set of transactions that are labeled as either fraudulent or valid. You split your data set randomly and use part to train the model and part to test or evaluate the model. So it's very important to randomly choose the data, since if you have some patterns of data following and choosing only the top 100 or some section of data would miss the categories of data. So it is always important to choose your data randomly to train it. And once you have trained the model, evaluate the model using the remaining test data. You use data you already know for the outcomes. So you can tell whether your model predicts accurately or not. So the accuracy can be defined in terms, we can say like 70% accurate, 80% accurate, something like that. And there are some of the common terms available in machine learnings that you must be aware of. So first is an algorithm. So it is basically a self-contained set of rules used to solve problems through data processing, math, or automated reasoning. And second is the anomaly detection. An anomaly detection is something which happens unusual or abnormal. So a model that flags unusual events or abnormal is the appropriate term, or values, and helps you discover problems. So for example, a credit card fraudulent detection looks for unusual purposes. So you being having a purchase over a defined regions, and suddenly a credit card is swiped somewhere around in different countries, and the system could detect it and automatically trigger a OTP or a pop-up asking whether it's you or not. So that's something which is anomaly detection. And categorical data that is organized by categories and that can be divided into groups. So for example, a categorical data for autos or any automobiles could specify which year, what is the make, and what is the model, and what is the price. And so that's categorical data. And then classification. So a model for organizing data points into different categories based on the data set. So which categories groupings are already known. And feature engineering, it is basically the process of extracting or selecting features related to a data set in order to enhance the data set and improve outcomes. And next comes the model. Module is basically it's a functional part in ML Studio, such as enter data module that enables entering and editing small data sets, and an algorithm is also type of module in Machine Learning Studio. And model model is basically a supervised learning model is the product of ML experiment comprised of training data and algorithm to train, and a functional module such as score model module. And numerical data has been as meaning as measurements or counts, so also referred to as quantitative. And the partition, the method by which divide the data into samples. So a prediction is something which is a forecast of a value or values from a machine learning model. So you might also seen the term predicted score. So however, the predicted scores are not the final output of the model. An evaluation of the model follows the score. So, and comes the regression, a model for predicting a value based on independent variables, such as predicting the price of a car based on its year and its make. So that's regression. Uh, so score and a predicted value. It is predicted value generated from a trained classification or regression model. So using the score model in ML Studio. So classification modules are also also returns a score for the probability of the predicted value. So once you have generated scores from a model, you can evaluate the model's accuracy using the evaluate model module. And last is the sample. It's a part of a data set intended to be representative of the whole. So samples can be selected randomly, as I said, or based on the specific features of the data set. So based on the input or the data set which you choose to. So next is the ML process. So ML basically starts with data, which can come from a variety of sources. So the data typically needs to be cleaned before it is used. And Satish should have showed you in the first session using the ML Studio. ML Studio includes modules to help with cleaning. So basically, cleaning in the terms, it's examples of cleaning would be it is when you have a large data sets of some values of some properties. It is basically including it includes removing rows with missing data, or for data which is not meaningful, replacing the missing data algorithmically using some constant value. Say if you have zeros in your data, replacing it with some constant of 5 or 10, and removing duplicate rows, and removing rows containing outliers. So in practice, cleaning the data can be very time intensive and often consumes about 50% of the time that required to build the model actually. Once the data is ready, you can select an algorithm and train the model by allowing it to iterate over the data and find the patterns in it. So that's how it works. So after that comes scoring and evaluating the model. So which tells you how well the model is able to predict outcomes. So all of this is performed visually in ML Studio. So this is how that pattern actually works. So once the model is ready, a few button clicks, you can deploy it as a web service so that it can be called from any client apps. So and next is the types of algorithms. So as you can see, supervised, unsupervised, and reinforcement learnings. So there are a lot of algorithms which you require, as you can see from here. So to train, to make a model, train and learn it, you need a lot of algorithms, and it is based on the data set that you chosen. So some of the uh, algorithms available are listed here. So supervised learning, it is basically the model is trained with huge amount of data, and using the algorithms based on the data set, and then it is used to predict an outcome in the future inputs. So that's how it works. There are classification algorithms, regression algorithms, anomaly detections inside the supervised learnings. So most supervised learning models uses regression algorithms to compute an outcome from a continuous set of possible outcomes. So for example, your score on a test. So that is something what regression algorithms about. Classification algorithms is another commonly used one. So to compute probability of an outcome from a finite set of possible outcomes. So for example, a probability that an email could be a spam, or a credit card transaction could be fraudulent. And anomaly detection is something, finding an abnormal or unusual pattern of occurrences based on the historical data. As I said, your credit card is usually used within a region, and it is somewhere swiped anywhere outside. So actually, abnormal would be the more appropriate term. So that's an example. And unsupervised learning. So here, the computer is not really trained, but is presented with a set of data and challenged to find the relationship between the data. So that's basically what unsupervised learning is all about. K-means cluttering is a common unsupervised learning algorithm. And then reinforcement learning. So it is basically learning on the job. So that is the system will never shut down, and it will keep on learning based on what is happening. So it is something like a baby that learns on growing. So these are some of the algorithms types that are available in ML to predict data of the future outcomes. So in this session, we're gonna see in detail about the simple linear regression. So linear regression, it is an algorithm. It has been around for hundreds of years and is widely used in statistical modeling. So the simple form of linear regression is, it has one input variable and one output variable. So various techniques are used to best fit a line to the data. So hence linear regression. So multivariate linear regressions is, it is similar but adds additional terms to the equations B2, B3, and so on. So training a linear regression models with millions of values can take time, but once the model is ready, trained, using it to perform predictive analysis is fast because running the model involves a little more than solving an equation whose coefficients have, already been computed during the training. So this illustration, it can be used to explain why picking the right algorithm is the key to for building an effective model. So if there is not a relatively linear relationship between input variables and output variables, then linear regression won't reproduce a robust predictive model. So fine. So we will see things in detail about linear regression. So we'll be having we'll be doing a math on how linear regression works and predict a future outcome for how the count of corona will be in the future in next 14 days. So that's how we are going to do in the demo session. So next comes the cheat sheet. So the cheat sheet is something that you could look for if you're not someone who's having enough knowledge in machine learning. So the Azure ML cheat sheet helps you find the right algorithm for a model, even if you are not trained data scientist. So that ever matters. You could have a look at the cheat sheet and do things simply and choose an algorithm. So one example is, if you want to use a set of input values to predict an output from a continuous set of values. So say for example a person's age you want to predict, use linear regression. And but if you are more interested in distribution of the output, you might use phosphorus quantile regression instead. An example of when you would use the later is using growth charts to access child development. So that's an example. And classification algorithm, by contrast, it's used to predict a value from a discrete set of values. For example, classifying an email as a spam or not. That would be an example. So you could see here, if you wanted to predict values, you can use regressions. If you want fast training a linear model, use linear regressions. If you want accurate long training times, then you could choose a neural network regressions. And you have several categories of data, predict between several categories, then multi-class classifications, and it is available online. You could just have a look on this, and so that um, you could learn on yourselves. So fine. So here we go. So we can predict. So the example we're gonna see in this session is, we are going to predict about. Uh, we have taken the statistics of corona for the last 30-45 days, and we are going to predict what it is going to be after the next 15 days. So using the linear regression model. So we're going to see how the linear regression actually works, so that it would give you an idea of how machine learning actually works in. So that after that you could go in and explore and apply it in various tools and see how it actually works fine, and how ML is efficient, and why do we need certain tools for using ML. So here we go. So yeah. So let's say I am taking this as an example. So to find a linear regression, so as I said, it's univariate. All you have is one input and one output. So on March 4th, which is the first 15 days of corona affected in India, so I have just taken here the count of India, and we're just going to predict what will be the positive cases of corona on April 18th. It does not mean that this is going to be the exact count, and we're just gonna give a try. I sincerely wanted this not to happen. We're just going to give a try based on the historical data we have, and this is just to give an idea of how predictions can happen. So this could be a lot more improved by choosing closer intervals. So here we have taken intervals of 15 days. So the first 15 days the count was 29, and for the next 15 days or after 30 days it was 129, and on April 3rd, after 45 days of corona's affected period, it is 3108, which is yesterday's data. So based on this, we are going to predict what is going to be the corona count on April 18th in India. So that's what we're going to do. So to predict Y on this particular date, so what we have to do is, this is the simple formula that we're going to follow. So Y is nothing but a constant plus a slope into X. So X is what uh, we are looking for. So it is the input variable. So X in our case is 60. And to find out this constant, so we have a formula which is y bar minus m into x bar. So now comes the x bar and y bar terms. X bar and y bar is something which is nothing but the averages of x's and y's we have. And to find out m, which is the slope, the formula is x bar into y bar minus xy bar by x bar square minus x bar bar. So we're just going to apply the simple math based on the data we have here, and what we end up is we'll be having some graphs something like this. So that would predict. So if we plot the values on those plots, so what we would end up is some graph like this. Right. So let's say if you're marking it somewhere here, and I would be ending up at something like this. So if we make a make an value based on this, we could end up some graphs like this, so that's what we're going to basically do. We're going to plot the values what we had absorbed, and based on that, we're going to see how it comes. So I have already uh, I already have a template which is required for us, to plot values. So I've done the enough works. I Here comes the dates. So on these dates, what are the values we have recorded? So I've just plotted those values in the graphs here. So on 15th it is 29, and then it is 194 here. It is somewhere around 3000 here, and we just gonna find out what would be the count on April 18th by applying this formula, and just fit it over here. It could be somewhere anywhere here or here or here. The graph could go this way or it could come down. So we have to we have to see how the trends are going on based on the calculations. So before we proceed, let's do the math. So now the x bar here is the averages of x, so which is clearly 45 plus 30 plus 15 by 3, so which we would be having as 30 here, and y bar is 29 plus 194 plus 3108 and divided by 3. I guess it is 1110, and the product of these two is 33300, and you multiply x into y bar, so which is 60, into 1110, so which is 66600, and then comes the x bar square, so which is 930 square, and x square bar is x square is, here we have the x, we are squaring every, I've already calculated the squares of every x values. So the average of these three values is what x bar square is all about. So 225 plus 900 plus 2025 divided by 3 comes 1050. Fine. So we have got the required values, and then we're going to just apply that in the math over here. So to see what is the count that comes. So 33300 minus 66600. So, and divided by 900 minus 1050. So which gives us triple 300 and negative of 150. So the value would be triple two. So the slope constant that we need is triple two. So to find out y we need b, and to find b we need m. So we got m, and now we have to find b, which is y bar minus m into x bar. So the b value is y bar, so which is here clearly 1110, minus m is 222, which we found recently, and x bar is 30, which is the average of x's. So it would be something around 1110 minus 6660, so which gives us minus 5550. So fine. So we got the b value, which is constant, and we found out the slope. So now applying that to the formula, y equals b plus m max would predict as the value of what the count is going to be on April 18th, which is 60 days after Corona has started affected in India. So the b is minus 5550 plus the m we had calculated is 222. So which is minus 5550 plus 13320. So that would give us 7770. So yeah, fine. So the count on April 18th, if we go at this rate, it's going to be 7770. And as I said, this is univariate. We have just taken into consideration the days and predicted the count. So this may not be accurate. I'm just giving an idea of how linear regression algorithm works in. So you could bring in many properties into considerations. You can bring in the nature of people over there. You can bring in the population into consideration. Then that comes, as I said, lots of coefficient comes into play, where the formula changes as b0 plus b1 x and something like that. So other values comes into play with the calculation that requires to perform will increase a lot. That brings in the complexity where you require machine learning to make you do the work for you. So fine. So we now let's plot this value on the graph here. So 7770 would be something which comes around here. So fine. So if we see the graph, we plot it as a graph here, what we will end up is we will end up having a graph something like this. So it clearly shows that it is on the growing trends. So this is how we can see that we can predict it for some other dates based on this uh, data by finding the slope and predict it how it can be in even farther in future. So that's what that's how this linear prediction works actually. I hope that gives you a basic idea of how linear regression actually works. And so um, this this on extension is what the ML Studio does. This manual calculation needs a lot of time in. So bringing in the tools and bringing in lots of inputs and coefficients, the algorithm becomes more complex and the calculation takes in more time. So that's where ML actually comes into part and gives you a high end. So yeah, so I'm going back to the slide. So I hope now you had a idea of what how the linear regression works in. So you can explore some of the algorithms as well, how it works fine, and how MS Studio or any other tool helps in helps in accomplishing your tasks to predict the future outcomes. So it's all about. So to give you some resources of machine learning. So this is one of the book which is available for machine learning. It's a good book and free. And another recommended book would be on Azure machine learning. Uh, it's predictive analysis with Microsoft Azure Learning. It is available in Amazon, and there are lots of other materials available on internet as well. So so that's it about ML 101. I hope you got a bit of idea of what ML is all about, and now just go on, explore what is ML, explore even more deeper, and learn what are the other algorithms available and what ML could contribute to your projects. And I hope you find this useful.